Lesson 4.3, equation of tangent to the curve. So today we're going to be taking it even a step further. Not only do they want the slope of the line, the curved function at a specific x value, but they want us to actually then write the equation of the tangent line. So if you think back to pre-algebra and algebra, think of linear functions that were like y equals mx plus b, or today we're going to talk about point slope form. So we've got this function. It's a quadratic. F of x equals x squared plus x minus 1. Find the equation of the tangent line of f at the point where x is negative 4. So our first step is always to find the derivative, derive this. So we'll have f prime of x equals, use your power rule, 2x to the first plus derivative of x is simply 1, your constant goes away. So now I can use this to specifically find the slope at negative 4. So I'll find f prime of negative 4, which will equal 2 times negative 4 plus 1. It would be negative 8 plus 1, which would equal negative 7. This is my slope, which back in algebra we called it m. Then to find the line, I have to find the point of tangency, meaning where is the point at on the graph. And Delta Math will not give you a graph. I put this on here because I want to show you visually what you're really finding. We got to plug this point and the slope into point slope form after we do that. So the point of tangency comes from the original function. We want to take this original function and figure out when x is negative 4, what's the y value. So we'll find just regular f of negative 4. That'd be negative 4 squared plus negative 4 minus 1, which would be 16. Minus 4 minus 1 would be 12. Minus 1 is 11. So I have an ordered pair at negative 4, comma 11. Now I'm wondering if you remember what point slope form is. Point slope form goes y minus your y1 equals m times x minus x1. So we're simply plugging into this formula. We'll go y minus my y value of the point of tangency is 11. My slope that I found was here. It's negative 7 times x minus negative 4, which will turn into plus 4. Now you can leave it like this. They'll take that answer. If you want to solve for y, all you would have to do is distribute and then add your 11 to its like term. So you get y equals negative 7x minus 17. So this or this would be your answer. Now let me show you what that's doing. I screenshotted this from Desmos. First I graphed the original function f of x equals x squared plus x minus 1. So we said it's a quadratic. It opens up because it's a positive x squared term. And then what we wanted to do was find the slope at negative 1, 2, 3, 4. Well, I had to find the point of tangency, which is kind of hard to tell. If I zoomed in, it would be easier, which was right here. And that's where I got the negative 4, comma 11. And I wanted to make a tangent line, which is hard to do with one point. But what we were able to do is derive it with our power rule quickly and then plug in, and we found that we have a slope of negative 7. So what this is doing is going down 1, 2, 3, 4, 5, 6, 7, right 1, and there's another point. So that would be the equation of the tangent line. Y equals negative 7x minus 17. And remember, this is the y-intercept, saying that where this tangent line would cross through the y-axis would be way down here at negative 17.